Cool. So I think I'm just reading few Redis documentations, and I was just going through a blog. So I thought, let's just record while I read. So this is not specifically like I'm just recording in general. So I'll just try to walk you through a blog. I'll just discuss my thoughts. And after reading this blog, I think there is a blog. 13 years later, does Redis need a new architecture? So this is the blog that I'm going to read, and during reading, I'll just probably discuss some my thoughts and whatever I know about Redis, and then I'll probably just jump you through some bonus. I'll just talk about the commands you should know if you're new to Redis. Um, just a context. So I've been using Redis for last 4 years now, and I fairly have experience around like different using different commands and knowing Redis very closely. Have scaled like to multiple nodes. I've worked across like at large scale, medium scale, small scale with Redis as well. So other than this, so let's just jump into it, I guess. Um, 13 years later, does Redis need a new architecture? So Redis is a bedrock technology, and as such, we occasionally see considering alternative architectures. A few years ago, this was brought up by KDB, and recently a new project, Dragonfly. By the way, this blog is from 2022, so that's the reason they have written that in the context. I think, by the way, there are different projects right now as well. That pretty much the database space is evolving, and there are different data sources out there. So it's pretty much a competition out there to get something out. Yeah. So new project Dragonfly claimed to be the fastest Redis compatible in-memory data store. I mean, this line is important. So Redis compatible in-memory data store. So, for example, let's take an example of Cockroach DB. If you have heard of it, right? So they are also like drop-in replacement. You can have a Postgres drop-in replacement. What's the reason for that? So so Redis is pretty like, for example, Postgres, just like Postgres has a very good community. People use a lot. Postgres people use a lot. So that's just like that. Redis is wildfire. Redis is used everywhere. A lot of companies, a lot of enterprise companies, individuals use Redis. So in order to get the customers, get the community, basically, you have to have basically compatibility with Redis so that people don't have to change their client. So what does that mean is, so for example, if you're using a Redis client for connecting to Redis, interacting with Redis, that doesn't eventually change. The underlying implementation, the underlying data store changes, but from a code point of view, doesn't change. So when we say Redis compatible, they probably implemented the Redis REST protocol, uh, the protocol we use to connect Redis. So I think we'll probably see what is talk about. So we believe these projects bring many interesting technologies and ideas worth discussing and debating. So here at Redis, we like this kind of challenge, and as it requires us to reaffirm the architecture principle that Redis was initially designed with, hat tip to Salvatore Sanfilippo, aka Anti-Reg. By the way, Salvatore started this project Redis, and I think he's part of Redis now, Redis Labs now. As Redis Labs is like basically the maintainer of Redis open source project. I mean, it's not open source anymore. Um, so while we are always while we are always looking for opportunities to innovate and advance performing capabilities of Redis, we want to share our perspective and some reflection on why the architecture of Redis remains the best in class for as an in-memory real-time data store like cache, database, everything in between. By the way, this is an interesting point. So Redis, I mean, usually when I say Redis, people treat it as cache, but Redis can be used in like different use cases. I'm going to talk about it later. Like there are ton of different use cases that you can use Redis to, and Redis has different capabilities. Like it has evolved from just being a cache, just having getter setter operations, to have different. I think you can just treat Redis as a data structure server, just like the way you write data structures, you implement data structures. Just imagine there are APIs for data structure. Redis gives you interfaces for basically hosting those data structure in Redis, correct? Um, okay, so In the next sections, we'll highlight our perspectives on speed and architectural differences as it relates to comparisons being made. At the end of this post, we have also provided details of the benchmarks and performance comparisons versus the Dragonfly project that we discussed below, and invite you to review and reproduce this yourself. Okay, cool. Um, the speed. The Dragonfly benchmark compares a standalone single process Redis instance that can only utilize a single core with a multi-threaded Dragonfly instance that can utilize all the available cores on the VM's server. Unfortunately, this comparison does not represent how Redis is run in real world. As technology builders, we strive to understand exactly how our technologies compare to others. So we did what we believe is a fair comparison, and compared a 40 shard Redis 7.0 cluster that can utilize most of the instance cores with Dragonfly using setup performance test on the largest instance type used by Dragonfly team in their performance benchmarks. That is AWS C6 GN 16x large. And in our trials, we saw Redis achieve 18% to 40% greater throughput than Dragonfly, even when utilizing only 40 out of 64 vcores. Okay, that's interesting. By the way, so if you read this line right, so Dragonfly compares standalone single process Redis instance. By the way, Redis is single threaded in nature by default. The main thread, like the main like Redis as a process, as a like this, there is a single main. The main thread is a single thread, right? So, for example, if you have a single thread, it cannot by default. Even if I have like a 16 core gigantic machine, let's say 60 core, 100 core machine, if I just start the Redis process, default, no arguments, no tweaking, nothing, it'll just utilize one core by nature, like the way it's designed, right? So, for example, if I just take, if I let's say I'm from Dragonfly team, I don't do anything. So, for example, I'll just take the Redis code. I don't do anything. I just run the Redis instance, no cluster mode, nothing. I'll just run that code base on my system and do a benchmark against Dragonfly. That's not a fair comparison as per it is, because by default it'll just utilize just one thread. Even if you have like one thread, just utilize one core. um, I mean, you can compare it to Node.js, for example. So that's the reason in Node.js, for example, let's say Node.js is also, it does have a like one single thread, like the main thread is just single threaded. That means, for example, if you have a four core machine, we run four instances of Node.js. For example, we use something called a PM2. I think you could just read about it. PM2 Node.js. I mean, this is just a process manager that we use. So I think this is how it works. I mean, just you just spawn it off. So this PM2 will load balance between these node processes. Like each node process is taking one core by default. So yeah, let's just see. Um, they use these commands set get, and I think set get commands. The pipeline was 1.1. Is this the actual Redis pipeline that are they talking about? Okay, we'll just read it later. We'll see what they're doing. So Dragonfly, RGB pipeline 1, 64% to 100% utilization, Redis 7.0 cluster. Okay, cool. So percentage 19% change, 17% 42% change, and 43% change. So they're saying like Redis achieved 18 to 40% greater throughput than Dragonfly. This is cool. Architectural differences, some background. So we believe a lot. We believe a lot of architectural decisions made by the creators of this multi-threaded projects were influenced by the pain points they experienced in their previous work. We agree that running a single Redis process on a multi-threaded core machine, sometimes with dozens of cores and hundreds of GBs of memory, is not going to take advantage of resources that are clearly available. I think this is what we discussed just now, and but this is not how Redis was designed to be used. This is just how many of Redis providers have chosen to run their services. Redis scales horizontally by running multiple processes using Redis cluster, even in the context of a single cloud instance. Um, I mean, that is what we're talking about. For example, Redis by default takes use a single thread. So you have to make sure that you run multiple processes of Redis, correct? And maybe that's logically separated. That's a different story. Like basically they are logically sharded, so that it's like a cluster. These are four processes part of the same cluster. So let's say you have a four core machine, you run four Redis instances, and I don't know, these are just four. You have four cores, you run four processes, and you just run four processes, and just imagine that these four processes are part of the same cluster, logically sharded, and the data is going to load balance. For example, the data is going to be routed. Like for example, if you have some algorithmic sharding, the data is routed wherever it's supposed to route. So you have four processes. The data is routed where it's supposed to be stored. Let's see, you have four processes, one, two, three, four. I set a data called A equal to B. Like for example, set name is called Sarthak. So what will happen is the name key, right? Wherever it's supposed to be supposed to be routed. For example, the third process is taking. It's supposed to name is supposed to be routed to the third process. It will route to the third process and get from the third process itself. So basically, they are part of the same cluster but logically sharded. Just giving you an example, mental model of how Redis should be thought of, and Redis skills. Okay, so I think we just read about that. And okay, not going to read this. Is how it. Okay, so Redis skill how to make multiple processes using Redis cluster, even in the context of a single cloud instance. We read that. At Redis, the company, we further developed this concept and built Redis Enterprise that provides management layer that allows users to run Redis at scale. With high availability, instant failover, data persistence, and backup by default. I think this is just a promotion. I think not just a promotion, but Redis Enterprise is a service that they provide. I mean, AWS has Elastic Cache. Similar, they have Redis Enterprise, where they are the maintainer. They have much more fine-grained control over, and they understand the optimization pretty well. I mean, it's pretty great. Enterprise is good. We decided to share some of the principles we use behind the scenes to help people understand what we believe are good engineering practices for running Redis in production environments. Thank God. Okay. Architectural principles. Run multiple Redis instances per virtual machine. Running multiple Redis instances per VM lets us. Okay, by the way, if you are a newcomer, you see the word VM, don't be overwhelmed. VM stands for virtual machine. So what is a virtual machine? How do I define it? Okay, so we have computer in front of us, right? I mean, okay, so VM is something like that. Just understand it. So we have computer in front of us, and it does have CPUs in them, correct? Our computer have CPUs, right? And which is responsible for running the code, correct? We have a computer, we have CPUs in them, we have code in them, code in the computer, and CPUs are responsible for running the code, correct? So just like that, Amazon, AWS, like Amazon AWS, Google, GCP, and Azure, Linode, these DigitalOcean, right? So these companies have computers and they have CPUs in them as well, but they don't sell something called, like they don't sell those computers exactly, like they don't sell those CPUs to us, but they sell something called a virtual machine. You can think like a computer can be like, you have one computer, uh, inside a computer you have multiple virtual machine. They have like logically separated virtual machine. They can have different operating system as well, like separated by operating system, separated, like logically separated. Like they have a computer, they have CPUs, but they don't sell CPUs. They sell something called a virtual machine, and those are logically separated, correct? I mean, I just sucked at explaining that, I guess. Okay, so running multiple instances per VM lets us linearly scale linearly, both horizontally, both vertically and horizontally, using a completely shared nothing architecture. This is always provide more flexibility compared to multi-thread architecture that's only scales vertically. Okay, so what they're saying is like, you have an instance, even if you have a single instance, they deployed multiple instance. Instance means you have a single machine, virtual machine. It does have, let's say, four core. They deployed four instances of Redis, like four processes of Redis, which shares nothing between them, right? And that's how they scale horizontally. Like you don't have dependencies on between them. That means these processes are independently running, correct? I mean, they must have a cluster manager. Like, for example, that's what they mentioned, like a management layer, which takes care of routing, sharding, everything pretty much, I think. And increase the speed of replication as the replication is done in parallel across multiple processes. Interesting. Fast recovery from the failure of a VM due to the fact that new VMs Redis instances will be populated with data from multiple external Redis instances simultaneously. Limit each Redis process to a reasonable size. We don't allow Redis instance to grow beyond 25 GB. I mean, 25 GB itself is huge. I mean, in terms of, if you, when I talk about Redis, like in memory store, and 50 GB while running Redis on Flash. I mean, Redis on Flash is also interesting. I mean, Redis. I mean, you can model Redis as running on, like, on the main memory, but Redis on Flash is like Redis on steroids. I mean, Redis running with an SSD. I mean, it's a little cheaper in terms of cost. So this allows us to enjoy the benefits of copy and write without paying penalty of large memory overhead when forking a Redis replication. By the way, Redis forks, um, like forking Redis for application, snapshotting, and append only file. So by the way, Redis does something called a forking. So while forking, so forking means it's going to launch a child process from the parent process, and it's going to take a snapshot of whatever is there in the memory. So copy and write is a technique. So what it does usually is that, so for example, while it is taking the snapshot, I mean, it's just gonna check. So if there are any in-flight messages that are coming in, it'll just ensure that, like, we just copy the def. Like, we don't, like, it avoids a lot of like unusual work. Like, for example, it's not an expensive operation. So if you just look at copy on write operating system, resource used in efficient operating system compared to program to share data efficiently. How it works? So COW shares the same data between programs until one tries to modify. When a copy is requested, the system creates a new reference to the existing data instead of immediately duplicating it. This is pretty interesting, pretty neat. This is what copy on write is, by the way. So I'm in, yeah. Um, Scaling scaling horizontally is paramount. The scalability to run your in-memory data store is horizontally scaling extremely important. Here are some of the reasons why I think this looks like better resiliency. The more nodes you use in your cluster, the more robust your cluster is. For example, if you run your data set on a 3 node cluster and one node is degraded, it's 1 out of 3 of your cluster that is not performing. But if you run your data set on a 9 node cluster and one node is degraded, just one out of 9 of your cluster is not performing. Okay, cool. Better resiliency. Easier to scale, it's much easier to add. Okay, that is fun. I think Redis, the way Redis is designed, I mean, it's like range based sharding, we can say. I think Redis has something like 16,000, some 400 something keys. Redis has. So every time you map a key, like set a key, that key is going to be calculated against the numbers that we have, the range that we have, right? Whatever range it falls in, that goes to that particular instance of Redis in a cluster mode. So, for example, if you want to add a node, it's much easier to add. So just the keys will be shuffling. I mean, in an efficient way, not in a positive way, basically. So it's easier to add or remove nodes. Gradually, scaling is much more cost effective. Scaling vertically, especially in the cloud, is expensive. I mean, I can agree. So, for example, if you're taking a 4 core machine versus an 8 core machine, the cost is like, it's not linear. I mean, it's going to be exponential whenever you do vertical scaling. Um, High throughput at Redis, we see many customers who are running high throughput workloads on smaller dataset with high network bandwidth PPS packet per second. Think about a 1 GB dataset with 1 million operations per second. Does it make sense to run a single node, blah 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 blah, at less than 20% of the okay. I mean, realities of Numa scaling vertically means that running two socket server with same multiple cores, large DRAM, the Numa based architecture. I'm not sure what Numa is. Maybe I'm missing out something. Redis Enterprise extend linear searchability to 200 per second. Interesting. I'm not sure what Numa is. Numa. Different Numa nodes. I'll probably read about it later. Um, This is on me. I don't know what Numa is. Numa is more challenging. Okay, so storage throughput limits. External disks like AWS, EBS don't scale as fast as memory and CPU. Obviously, we know that. There are storage throughput limits imposed by cloud service providers based on machine class being used. Therefore, the only way to scale a cluster to avoid issues already described and meet high persistent data requirements by using horizontal scaling. By adding more nodes, more network attached disks. Cool. Ephemeral disk. An ephemeral disk is an excellent way to run Redis on SSD. Yeah, Redis on Flash, right? I think this is a way to save a lot of cost. I mean, you won't get the, I think, sub micro millisecond latency. I mean, the latency will suffer a bit, but I mean, you will save a lot of cost. Enjoy the cost of disk based maintain Redis speed. Again, when the disk reaches its limit, the best way in many cases, the only way to scale your cluster is by adding more nodes and more ephemeral disk. Commodity hardware. Lastly, we have many on-premises customers who are running a local data center, private data cloud, private cloud, and even in small edge data centers. In these environments, it can be hard to find machine with more than 64 GB of memory and 8 core CPUs. I think this is a very fair point. Like fair point. Again, the only way to scale is horizontal. I think they try to emphasize is like you should horizontally scale. Do not build a system to make sure you utilize vertical. You don't have to vertically scale. It's expensive at scale, and it's sometimes I mean, it doesn't make sense as per whatever we are discussing. I mean, that's fine, but at a certain extent anyway, you're not going to use vertically. You anyway have Dragonfly also needs to scale horizontally, right? But even if it's for a particular node, so for a particular machine, if you're running once instances of a Dragonfly, it is multi-threaded in nature. It will make sure that it extends its capability. Like for example, it is utilizing the hardware to its extent, but that doesn't mean it won't scale horizontally. They have to add multiple instances of Dragonfly, and they need to have a cluster manager which manages these Dragonfly instances. So we appreciate fresh, interesting ideas, technology from community. Okay. Appendix, stuff and benchmarks. We use built-in resource from the source. Dragonfly was built from the source and it goes verify. Okay, got it. I think these are just. I think you just refer to it. They just try to say that OSS Redis 4.3 million operations per second, where both achieved the latency P50 latency of this one 390 seconds. I mean, very slight difference. Redis throughput is greater by 10% and 18%. Get pipeline, let's see, 22 million operations per second. Average latency. Okay, they're trying to say Redis is still faster. Redis pipeline. Okay, this is the machine configuration. This is a pretty giant machine, by the way. They used a client called running matter memtier benchmark. I'll probably read about it. Memtier benchmark. Redis Labs. Okay. This is also well maintained. I think I just see a contribution just 3 weeks ago. I think that's what I had for this blog. I think I'll just probably read some commands. I'll just make a video while just reading, going through the commands documentation. Yeah. See ya.